Okay, so we start off with A equals to pi times P, 2P plus Q. We want to make Q the subject. So I'm going to get rid of this pi P first. I'm going to do that, get rid of it by dividing both sides by this. Yeah, sure, I don't need it. I don't want it back for me. Okay, thanks. So we divide by pi P on both sides. A over pi P equals to 2P plus Q. Now making Q the subject then becomes really easy. It's minus 2P on both sides. So Q equals to A over pi P minus 2Q. That's all. You don't even need to combine it into a single fraction. Why? Okay, so next one. We have a why? Hey, sorry, P minus 2P. Like this, okay? It cannot have P, cannot have Q on both sides. Then that's not making Q the subject already. I blur. Okay, next one. So we have a solid made from a cylinder and two hemisphere. Two hemisphere. If you combine together, it gives you one sphere. Okay. Radius R, length 2R for the cylinder. Hemisphere radius R. Of course, it has to be. So total surface area of the solid is twice the total surface area of the cone. Radius R, smart by L, find L equals to R. Form equation. The first surface area, 4 pi r squared plus pi times 2r times 2r. This is our what is it? 4 pi r squared. Oh, okay. This is the surface area for the sphere combined. So instead of finding surface area of sphere, divide by 2, then times 2 again. Just put it together, 4 pi r squared. Combine the two curved surface area of the sphere, then 2 pi r. This 2 pi r represents the circumference of the cylinder, of the circle of the cylinder. This is the circumference. We multiply by the perpendicular height of 2r. So we get a curved surface area of the cylinder over here. So total surface area, when you add them up, you get 8 pi r squared. Now, they continue to tell us that the total surface area of this solid, meaning our 8 pi r squared, is twice. So they are saying that our 8 pi r squared is equal for twice, 2 times. 2 times of what? Total surface area of a cone, radius R, slant height L. So here we have a cone. Draw it out if you cannot visualize. Draw it out. Radius is R, slant height is L. Total area for this is made of 2 parts. First, we have a circle at the bottom. Then we have the curved surface area of the cone. 2 parts. First one, let's do the curved surface area of the cone first. Formula given to you. Pi r L. That is the curved surface area of the cone. Pi r L. Radius is R. L is, well, they didn't tell you, it is L. Then we need to add pi r squared. Pi r squared being the area of the circle at the bottom. So we have formed an equation. What do we do with that? They said find the find L, right? Find L in terms of R. Okay, then it becomes just making L the subject. A few ways you can go about doing it. In this case, you can expand it and make L the subject. Okay, I'll show you another way. So this is fine. But I'll show you another way. From this step onwards, I want to find L, so I get rid of the 2. I want to find L, I get rid of the 2. I divide by 2 on both sides, so I get 4 pi r squared equals to pi r L plus pi r squared. Both sides divided by 2. Next, get rid of this pi r squared by subtracting on both sides. So on the left hand side, you have 4 pi r squared. On the right hand side, you have a pi r squared. So minus lah. Left with 3 pi r squared equals to pi rl. Next one, I am trying to find L only. So I need to get rid of the pi. I get rid of pi by dividing by pi. So we will end up with 3r squared equals to r times L. I only want the L, so I need to get rid of the r. Get rid of the r multiply, we get rid of it by doing division of r. So we divide by r on both sides, we end up with 3r equals to L, meaning L equals to 3r. Okay, so these two steps, actually these 3 steps can be combined into one. Can? So if you choose to expand it out, make out the subject, also okay. I just prefer to do the one on the right hand side. Next one, cross section gold pendant. It's a quadrilateral. Okay, quadrilateral, 2 right angles and a circular hole. All dimensions in centimeters. Diameter of the hole, H-O-L-E. Diameter of the hole is 0.8 cm, implying radius equals to 0.4 cm. These are things that you must catch really quickly. Even if the question didn't ask you for it, you know that radius is found from the diameter as well. The uniform thickness is 0.3 cm. So apparently this being the cross section, it has a thickness. And I'm going to attempt to draw the thickness for you now. Okay, so here is my thickness, and it shows that it says that it is 0.3 cm. So this part 0.3. They further tell us that the mass of 1 cubic centimeter is 19.3 grams. Effectively, they are telling you density. Do you realize that? Density over here. The density of gold is 19.3 grams per cubic centimeter. And then the next line tells us that, the price of gold depends on the weight. Does that make sense? The price of gold depends on the actually mass, because they're using gram. The price of gold depends on the mass. The greater the mass, the more expensive it is. Makes sense? And then calculate the value of the gold in this pendant. So in order to find the value of the gold, how much it is worth, it depends on its mass. If I can find the mass, I can find the value. But to get to the mass, I need to know the volume, because I only can get the mass from this sentence, which is effectively the density. To get the mass, I need volume, because the mass and volume, they are linked together by the density. So now our objective is to find the volume. The volume of this object is given by base area times perpendicular height. It is a prism. So base area times perpendicular height. Aloysius, you look very focused. Are you focused on the question, or are you focused on something else? Yeah, you copy. I know, copy already. But are you focused on this or something else? Don't want to answer, I also know your answer. Focus. Anyway, you copy means you didn't know how to do lah. Then now that you copy, then don't need to listen already. Do you know how to do already? See, you're not using your time wisely. The objective is not to copy, the objective is to listen to my explanation. So we need a cross-sectional area multiplied by the thickness to get volume. Now, cross-sectional area is our first problem we need to solve. What is the cross-section area? They tell us that it is made up of a quadrilateral with 2 right angles. So I can divide it as such. Draw a vertical line down. And I end up with 2 right angle triangles. Area for triangle is super easy, isn't it? Area of triangle, half times base times height. The height being the perpendicular height. So you identify where is the base. The base will be this 1 cm. The perpendicular height is the 2.1. So we have half times the base of 1 times the perpendicular height of 2.1. That is the area for 1 triangle. But we have 2 triangles. So you times 2. They are symmetrical triangles. So times 2. Oh, but there's a hole over there. We need to remove the area of that hole. So you minus away pi r squared. This will give us the exact area in terms of pi for the pendant. Area only. So notice that the teacher left it in terms of pi. Why? Why leave in terms of pi? You feel very tempted to press calculator and get number? Are you very tempted to do that? If you do that, will you expect to see many digits, many decimal? Yes, right. Is that a good thing? It's not a good thing because it is no longer exact. Hey, can you visualize this object? It's very tiny, right? 2.1 cm by 1 cm only. And the thickness is 0.3 only. The moment you round off at the start, your answer is going to be very inaccurate. Okay? Next, with this cross-sectional area, we're going to find the volume. So volume of the pendant, you multiply by 0.3. And here in 5SF, if it is up to me, right? I mean, it is up to me. I will not evaluate. I don't want to evaluate. I just put it down as 0.3 times 2.1 minus 4/25 pi. Leave it like this first. Because later on, I'm going to do something with it. What am I going to do to it? Yes. What am I going to do to it? We are going to find out the mass from the density and the volume. So 1 cubic centimeter has a mass of 19.3. What about this particular volume? So multiply them together and you get the mass in grams in 5SF. So although I emphasize that I like to work with exact values, there comes a point in time where it becomes too long already. The benefits, the advantages of writing in exact form does not outweigh the convenience already. Because the exact form, if you really want to continue, it's going to look like this. 19.3 times 0.3 times open bracket 2.1 minus 4/25 pi. Yeah, very exact, but a bit too long lah. So for convenience, at some point in time, change it to 5SF, make your life easier. Okay, you have to balance it yourself. You have to decide by yourself. Just remember the guiding principles. Exact is best, but don't do it at the expense of writing very long expressions. Next, we get the value. For 1 gram, it costs $69.65. 1 gram, you know how much is 1 gram? I don't know whether this is a realistic value of gold. Maybe it really is. That's why they say precious. 1 gram, $69. So for this tiny pendant, it costs you $644. Is it realistic? Is it? I have no idea. I don't own any gold. If your parents they have some gold jewelry, ask them how much it costs. Of course, the heavier it is, the more massive it is. The word massive deals with mass, not size. The more massive it is, the greater the value. So thick and heavy gold necklaces, target for robbery law. So expensive. Okay, next one. Question 3. We have a rhombus. Rhombus didn't say square, didn't say parallelogram. It is a rhombus. So straight away, indicate that all same length. Drawn inside a rectangle, okay, which is inside a circle. So creative. The rhombus has sides 10 cm. So all these will be 10, 10, 10, 10. So you have 10, 10, and 10. And then the length of the shorter side of the rectangle is 13. So this being 13. Straight away, you should be thinking about some numbers that you require already. All right. For example, what is the length of the longer side of the rectangle? That's probably something they would ask. For example, what is the radius of the circle? That is probably something that they can ask as well. Calculate circumference of the circle. So to find circumference, we require radius or diameter. Okay, because the circumference formula is given by 2 pi r or pi d. Okay, so can you tell the radius or the diameter of the circle based on information provided over here? Can you tell? Give you some time to stare at the diagram. I'll pause the recording first. Stare at the diagram recording. So the radius is actually 10. Oh, you did something long, is it? The Pythagoras, right? Okay, so the circumference is actually 62.8, 2 pi r, 62.8 cm to 3 sm. Whenever I see this type of working out, I don't like, because I'll be wondering what was the previous 5 SF value in case I need it later on. Okay, but I'm sure you can do it by yourself. Next one, calculate the area of the rectangle. So area of this rectangle, we require length times breadth. 13 cm was obtained already. Now we will need to find out. Okay, so what Aloysius told us to draw just now was very useful. We need to find out this distance, because combined, they give us the height of that rectangle. We got 13 already. I need to multiply with this value. How much is that value? So forming of right angle triangles, you naturally have formed right angle triangles here already. We know that. Let's take this triangle as an example. Okay, what's the information that we have? We know that this is 10. Its hypotenuse is 10. We know that this distance is 6.5. Why? 13 divided by 2 is 6.5. So then we can get the vertical distance. We are able to get this using our Pythagoras theorem. With that, we multiply by 2, we can get the length of the vertical height of the rectangle. So I'm going to do the working on the right hand side over here with its space. So height of rectangle is 2 times. 2 times out, because we've got one over here and another one, they are the same. 2 times of this distance, which is given by our Pythagoras theorem, 10 square minus 6.5 square. If you're very particular about showing working, where did the 6.5 come from? If the marker is very particular about it, where did the 6.5 come from? Then don't skip a step, 13 over 2. Okay, and this will give us the height of the rectangle. So then the area will be 13 times 2 square root 100 minus 169 over 4. So this is the exact value. Of course, we need to evaluate this. Okay, show you the answer straight away. Area of rectangle based on this, 198 square centimeters to 3 sm. Okay, if you had worked it out, you will get the same answer. Is that part C? No, part B only. Okay, so don't worry about copying. This will be uploaded. Question 4. Here we have a design drawing a large circle and semicircles. So one large circle and 2 smaller semicircles. One of the semicircle is shaded gray. The other smaller semicircle is unshaded. So the diameter as shown, 2 kr versus 2r. A lot of unknowns. And plus, this big circle has its own diameter as well. So in this question, there are 3 different diameters. They only provided 2. Can you find the third diameter? Can you find the third diameter from the diagram? Omera, can you find the third diameter? Small diameter is 2r. Big diameter is 2 kr. What is a big circle's diameter? What do we need to do with them? Yeah, add them up. Add them up, you get a big diameter already. Then divided by 2, you get a radius. So you can find area already. Okay, let's see what exactly the question wants. Show that the area of the large circle is given by the formula blah blah blah. Based on what Omera helped us with, we can find the radius. then area of the large circle must be pi r squared. So diameter of the large circle, yes, we add them up. Radius is, we divide it by 2, you get r times k plus 1. This is the factorized form. Next, to find the area, it is simply pi times the square of the radius. But the radius is given by r times k plus 1. So be very careful about your brackets and your expansion. So the area, pi r squared, k plus 1, close bracket, square. Okay, now, they tell you in part B, find in terms of pi and r, the difference in area between shaded and unshaded region when k is equal to 2. Now, instead of leaving it as an unknown k, they tell you that k has a value, it is 2. The difference between shaded and unshaded region. So we need a plan. The difference between shaded and unshaded. Of course, you must find shaded region. Then minus unshaded region. That is the difference. So shaded region for this semicircle is pretty easy. Shaded region, quite easy, pi r squared divided by 2. Now we have another shaded region found here. To find this shaded region, not too difficult also. In the first part, part A, you had the area for the big circle. All you need to do is to divide this by 2. Divide it by 2 to find area of biggest semicircle. Take away area of unshaded tiny semicircle. So with that, you found the remaining shaded part. With this remaining shaded part, you add it to the previous shaded part, you get the area of the total shaded part. And then they wanted the difference in shaded and unshaded, right? Which means now I need to find unshaded area. Hey, we already have area of the entire circle. You have area of shaded part. Unshaded is very easy. Just minus lah. So you are able to get this area, unshaded. Difference, subtract. Simplify. Substitute k equals to 2, get answer. Difference in area. Okay, there isn't much time already. Cannot copy finish? Never mind, it will be uploaded. So now, because I will be